Hi guys, welcome back to the channel. Again, Jag here. And today's class we're going to cover grade 11 math, and the topic is going to be on the discriminant. And the discriminant is part of basically the quadratic formula, which you probably remember from last year in grade 10 math. Okay, the discriminant basically tells you the number of solutions. Okay, so say I have a graph that looks like this. Okay, and my parabola is just like in the air here, and I can see that it is not intersecting the x-axis at all. Okay, so in this case, basically, there would be no solution. Okay, so just like that, if I use the quadratic formula, I'll notice that underneath the square root sign, I'm going to get a negative number, and that's what the no solution basically means. Okay, the second scenario will be like this. Okay, so if I look right here in this example, okay, I can see that the parabola is intersecting the x-axis, but only at one point. Okay, so in this example, okay, we're going to put one solution. Okay, one solution, or there is one root, is another name for it. Okay, and in this last example here, okay, I'm going to draw my parabola. And you notice that it is intersecting the x-axis at two separate points. Okay, so there's one point here and there's one point there. Okay, so basically I have two solutions in this last example. Okay, or there are two roots. Okay, the teacher will most likely use roots, or there are two zeros, which all mean the same thing. I'm just talking about the x-intercept. Alright, so these are the three different types of solutions I can have. Okay, so with that, let's try an example from the textbook, okay? And usually the question will just say, use the discriminant, okay, to find out the number of solutions. So the question isn't actually asking you what the solution is, okay? If it did ask you for the solution, I have to use the whole quadratic formula. Okay, so I'm going to put example here, okay? And so basically this example is saying, use the discriminant to determine, okay, the number of roots of each quadratic equation. Okay, so let's try this one here. So again, I'm using the discriminant only for quadratic equations, okay, to find here how many solutions are there going to be. Okay, so let's try negative 2x squared minus 3x minus 5, okay, which is equal to 0. So this is basically my quadratic equation. What I'm going to do now is plug it into the discriminant, okay? So this is the formula for the discriminant. So I'm going to write it here one more time. Let's put discriminant, okay? Which is part of the quadratic formula. It's b squared minus 4ac. And I noticed that this is what is found in the quadratic formula underneath the square root sign, okay? And again, that will tell me the number of solutions. So just like I mentioned, under the square root sign in the quadratic equation, if I get a negative answer, that means there isn't going to be any solution. Okay, so this is just going kind of a step further. So this negative 2 is basically the value of a, okay? The middle term is the value of b, all right? And this last term is the value of c. So just like that. And I'm going to just plug it into this formula for the discriminant. So the b is negative 3. Again, make sure you're taking the sign that is in front of the number. Okay, so negative 3 squared minus 4 times a, and I notice the a value is negative 2, okay? And the value of c is going to be negative 5. Okay, so all I did here was just plug in the numbers into the formula, okay? And I'm actually looking for what the answer is here. So let's write it out. So we're doing 9. I'm doing 4 times 2, which is 8. Okay, and 8 times 5, which is 40. So I'm going to subtract 40. Again, make sure you notice the signs, okay? These two negatives will cancel out, okay, which will be positive. But the positive and the negative sign is giving me a negative, all right? And again, if you're not sure, just put it into the calculator. That's not a big deal. All right, so I'm going to do here 9 minus 40, which is equal to negative 31. Okay, now basically, when I use the discriminant, I want to just look at the sign. Okay, because this value is less than 0, okay, we're going to be, therefore, there are no real roots. Okay, we are not actually graphing out the quadratic functions here. Okay, but if I were to graph it out, I would notice that there are no real roots, and it would basically be this first scenario. Okay, so it doesn't really matter where the quadratic function is. When I graph it, okay, it should just not intersect the x-axis because there aren't any real roots. Okay, now say that the quadratic function has one real root. That would be basically the example that we did right there, where basically it's intersecting the x-axis at one point. Okay, that would mean that it's one real root. Okay, and the way to show that is it's basically going to be equal to 0. So I'm going to write one real root. Okay, and basically in the last scenario, I'm going to write it at the top here. Okay, and in the last scenario, if your value for the discriminant is positive, which means it's greater than 0, there are going to be 2 real roots. Okay, so again, I should memorize these 3 different scenarios. Okay, so when I'm applying the discriminant formula, I can basically right away tell how many answers and how many solutions the quadratic function is going to have. Okay, so once again, for the discriminant, it tells you the number of solutions. It doesn't exactly tell you what the solution is. In order to do that, I have to apply the whole quadratic formula. All right, so if there are no questions, that's going to bring this video to an end, and I hope everyone learned how to apply the discriminant formula to figure out the number of solutions for a quadratic equation. And again, if you have any questions, you can feel free to just email me at jaggy5patel@gmail.com. Please don't forget to subscribe to the channel and click on the like button below because it makes a really big difference. So thank you for watching this video, and I'm going to see everyone next time. Bye!